Hello, my name is Ryan Powell, and today's tutorial is on casting. To understand this tutorial, you should have a basic knowledge of three data types, that is, double, int, and string. Now jumping into this, we already know that doubles can hold numbers with decimals inside them, such as 3.14. However, if you try to assign that value to an int, you will receive an error message. Possible loss of precision. It required an integer, but it found a double. So how do we fix this? Well, there's one simple solution, which is to do what's called casting. You can tell it what type you want to change it to, and then what value you want to change. So if we look through this line, we see we're creating an integer data type called whole num. We're taking the value of 3.14 and casting it into an int here. We recompile, compilation complete, it worked. Now, it did work, but only to a certain degree. So if we do a system.out.println line to see what the value of whole num is, you may be a little bit disappointed to find that it's not quite what we passed in. As a matter of fact, it is 3. Like we already know, ints can only hold whole number integers. So the computer did the only thing that it knew how, and it just completely chopped off everything after the decimal place and assigned the new value to be only 3. Now, there are also other ways to cast. Let's take, for example, some simple math. 3 divided by 2. We're going to system out print that, and the result, surprisingly, is only 1. Now why is that? 3 divided by 2 does not equal 1. Why is it showing 1? Well, what's happening here is we're printing the values 3, which the computer sees as a whole number integer, and 2, another whole number integer. So it does the only thing it knows how, divides 3 by 2, gets 1.5. It still believes that this should be an integer, so it truncates or chops off those last decimal places and assigns the value of 1. So how can we make it print out 1.5 as it really should be? Well, the answer is actually pretty simple. We just add a 0.0 after the number. Now once the compiler gets to this number, it sees that it has a decimal and it's a double. It's no longer a whole number integer. Same with the 2. We compile and run this class again. Now we get 1.5 as it should be. So that's another simple trick to remember. Now, later on in this class, you may be using tools such as JOption Pane to get input from a user, or scanner, which you may have already used. So when you get input from those methods, it'll often be in the form of a string. But what if you want it to be an integer or a double? Well, the creators of Java foresaw this problem and programmed in a great way to get around it. We can go to whole num and assign it the value of input. Now, if we do it just this way, obviously we're going to get an error. So we have to fix it. Well, whole num is an int, and the creators of Java created the integer class. And within that integer class, they gave us a method called parseInt. We can call this method and pass in the input variable. We recompile this, run it, and it works. So just to prove to you that it did work, we can do another system.out.println to see what the new value is. So before we run this, I just want to quickly explain what's going on here. we have a string variable called input with a value of 1, 2, 3, 4. We're now assigning the whole num integer int data type variable using integer.parseInt and then passing in the input variable. Then we're going to print it out, see what we get. Compile, run, we get 1, 2, 3, 4. Now, integer has this, double has this, and there are a few other data types that also have this data type.parseInt. I recommend you look into the Java documentation to find out which ones have it and which ones don't. Also, in the main way of parsing, which is to do this, which is the data type and then the value, you can do this between almost any data type. So that's been today's lesson. I hope you have a great day. My name's Ryan Powell. Adios.